Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is my Moto Rush controller. And you are looking at the left set of MOSFET drivers, and you are looking at all the flux and rework that was done on this board because everything here died. Everything here died, and they had to do massive repair to get this board working again. This is called a refurb. This is not a new product. If it was, all those components would look like these legs on this 7805. They would look like those capacitors. They would look like this buck chip. You can see that the solder looks very different. The solder is very uniform. You don't have flux all over everything because this is all components that are replaced with a robotic arm and reflow soldered. All of this stuff blew up and died, and Moto had somebody sit down and replace all these diodes and MOSFET drivers and hand solder them, and then didn't even bother cleaning up the flux. And they did the same thing over too. All of this stuff died, and they had to replace all of it and hand soldered everything in place. And if they had this been a brand new board, it would look like this linear regulator. You can see no flux around it, very uniform solder joints because everything is robotically placed. The solder paste is placed in very specific amounts. And everything there is all reflow soldered, and it looks very much like this. This is all hand soldering. This is all repair work, period. So anyway, let's go through the components on here. Oh, I forgot one little detail. If you remember in my last video, this stuff was also all equally grungy like this is, and with some basic solvents and a toothbrush, nothing real special. It is a trivial effort to clean all that stuff up and make it look so much better. But Moto, they literally don't care. They literally think you're an idiot and that you're too stupid to recognize massive repairs on a board, and will just sell you anything they can just because they are unscrupulous and dishonest and think that selling refurbished and repaired products as new is okay and that you won't mind. I mind heavily. New is new. Used and damaged and repaired is used and damaged and repaired. The two are very different things. You do not sell people used, damaged, repaired stuff as new. You don't. That's dishonest. It's disreputable. It is disrespectful. And it's offensive as hell. All right, so let's talk about that little chip right there. So that is a Max 485, and that is an RS485 transceiver chip, hence the name Max 485. That's commonly used in serial communications. I've seen chips very similar to that on a lot of circuit boards. So you've got ones and zeros that you need to protect on the outside, or you need to boost the voltage level from logic levels to something else. Isolation, protection, things like that. And that's what little chips like this do. I've also looked up all these little diodes, so you can see the T3s and T4s on them. These are just two different variants of a Schottky diode. I think these are 40 volt, and I think these are 24 volt. I did look up the data sheets just to find out what they were, because I thought they were TVSs, and they are not. All right, so up here, that little guy right there, so you can see it says U3018. That is a buck chip. In other words, it takes the battery voltage in and drops it down to 12 volts. And those things are rated for a maximum of 200 volts, but their operating maximum is really 180 volts. So it's a kind of a pretty cool little buck chip. I'm going to probably end up buying some because there are times when I need a little DC to DC converter like this, and that little guy's going to serve a lot of good uses for me. So yeah, I'm probably going to reuse that chip myself. But, it's doing what its job is. And so this little bit of circuitry right here, that capacitor, a couple diodes, little capacitor, things like that, that's all part of your main DC to DC. This is, you can't see it because it's covered with crap. This is a 7805 linear regulator. They basically produce 5 volts out. And, it's got a couple filter capacitors and a diode for making sure current flows only one direction. But, yeah, that's all that's really doing. Also, over here, so that AMS 1117, 3.3, indicating this is the 3.3 volt version. So this little linear regulators, they get used quite a lot. So I retract what I said before when I basically ranted at Moto for using a cheap little linear regulator on their board. Why aren't you using a DC to DC? I do still prefer DC to DCs, but these little guys see a lot of use. So, okay, whatever. Sorry, guys. I'm willing to change my opinion on things if there is compelling reasons for it. So I do for this little chip right there. All right, so let's look over here at all this massive rework, all this repair done. So those two gate drivers are in parallel. Those two gate drivers are in parallel. So this one runs 8 MOSFETs, that runs 8, that runs 8, that runs 8. And that is the drive electronics for two different boards, the middle power stage and the bottom power stage, and, two different sets of phases, essentially, per each one of these. So on these little chips, and let me grab some pointy tweezers, I've looked up the data sheet on these things, and these are 600 volt max MOSFET drivers. And on the data sheet, one of the things I wanted to find out is if these gate drivers run independent of each other. And so I needed to find out what the actual legs were on them, and now I have. So this leg is the high leg. In other words, that's the leg that turns on, or gets the input signal to turn on the high side MOSFETs, and that's the one that turns on the low side MOSFETs. And you have the same thing here, high side and low side. So that's what those legs do. So this is called I high and I low, I high and I low. And you'll notice they have these little 102 or 1K resistors coming off them. Those are current limiters. And yeah, you can see it very nice and clearly. There's a little circuit trace that runs right over here to here. So that's on the low leg. So you've got I low right here with a resistor going to I low over there. And under one of these two pads, there's a via that then goes over to the CPU. But anyway, those legs are 100% in parallel. And you can see that 1K resistor right there goes to that via. And that one goes to that via. And when I put my multimeter from here to here, I measure 0 ohms. Because, once again, they are completely in parallel. I didn't bother checking this one. Instead, I went over to this one and did the same thing. And so this time here, you can see the 1K resistors, and here's the vias, and here's the 1K resistors, and here's the two vias. So when I measure from here to here, in other words, that's I high, or input high, I measure no ohms, or, very close to 0 ohms. And when I measure from here to here with my multimeter, I also measure 0 ohms. And the reason why is because this MOSFET driver and that MOSFET driver are both getting the exact same control signals at the exact same time from the CPU at the exact same time from the exact same output leg. So, yeah, my theory was, or this was somebody else's theory they presented to me, and the proof is in the pudding that this isn't the case. The theory was that the middle power stage only runs when you need high current. And all the rest of the time, it doesn't run at all. And if this MOSFET driver and that one were enabled separately from each other, then that would possibly be true. Thing is, though, is their input legs are 100% in parallel. These chips do not have like an enable pin on them, so you can turn one off separate of the other. They're just simply on, and they're just listening to what their input legs do. So no, there is no turning off the center power stage. It's on the entire time the bottom power stage is on, period. So it sits there and essentially cooks in its juices because it has such sucky cooling. Basically almost none whatsoever. So yeah, so much for that theory that the middle power stage only gets used when you need high current. Nope, it runs all the time, which is what I thought, because I really honestly didn't think that Moto was clever enough to do something like this. And, well, they're not. Anyway, let us move on. Yeah, there's nothing else to see here. Again, these T3s and T4s are just Schottky diodes. This little guy right here, you can see it says 339. That's an LM339. It's just a quad op-amp chip. Nothing particularly special about it. Basically makes little signals into big signals, and that's that. I have since looked up these little parts. So this little thingy right there, that is... Gotta find her again. There it is. That is a VPS 8504. The data sheet is 100% in Chinese, so I had to use Google Translate to find out what that was. But this is an isolation transformer driver. And this thing here, which I said in a previous video, was an isolation transformer. And back when I was doing the Pro teardown, I didn't know what it was. But yes, that is an isolation transformer. And specifically, it is an 85BB-01A. It's good up to 100 or 1500 volts. So yes, essentially what's happening here is you have some high side stuff going on here, and you need to be able to isolate that from the low voltage DC side that's like all operating at like say 3.3 or 5 volts. And you want to make sure that you don't get stuff crossing from one to the other, because that tends to be bad. So use an isolation transformer, and that's what that guy does. So this little chip right here, which you can see on there, says ISO 1050. That is a CAN bus chip that has onboard isolation. So it uses capacitive isolation, which basically means that you can't get high voltage across the thing. The capacitor kind of limits that. So once again, stuff that's bad on the outside should get blocked by this, so that you only get logic level signals on the other side. So here is your, here and here, I think it is your two I/O pins coming out. And here are your two I/O pins coming in, and they go over to here. So yeah, that's your CAN bus transceiver chip. And of course, this is the STM32F103 CPU. In the Pro controller, at the time, I was under the impression that the CPU didn't have the legs to be able to run any kind of FOC control. And I've since discovered that there are, in fact, FOC libraries for it. So there's a fairly good chance that this controller really does run a basic set of FOC functionality. So that's cool. That's better than what I thought it was. Yeah, and FAR Driver, in fact, uses the exact same libraries, and this is FAR Driver development here. I don't care what Moto says otherwise, or how they lie and dip and dodge. That's what it is. And so, yeah, there is some basic FOC, field-oriented control functionality in there, just not the full suite like what you'd get with VESC or ASI or, Nuclear, for example. All right, so these 4 pins right there, that you can see has a plastic piece on top of it. That's because you're supposed to mount something on top of here. Wonder what that is. Yeah, a little piece of pollution or something. Yeah, that's super cool. Anyway, yeah, you're supposed to mount a part on there, aka the Bluetooth module. And as we know already, the Bluetooth module is on the bottom of the board, not on the top. So I unsoldered it. So I wanted to figure out why they didn't mount it to the top of the board. And now I know why. So when I put this on the pins, oops, kind of missed it there. There we go. When I put it on the pins, you can see the buzzer is in the way. So rather than doing a minor bit of redesign to move the buzzer out of the way, instead they put the Bluetooth module on the bottom of the board where signal penetration sucks. Yep. Once again, Moto has done the obvious thing. Let's disappoint everybody by bodging things together rather than fixing anything and doing a proper redesign to get the buzzer out of the way of the space where the Bluetooth module has to sit. Instead, let's just do the easy thing that takes us no effort whatsoever and slap it on the bottom of the board instead. So once again, Moto, good job. You idiots. You can see the 2 current coils in here, current sensing coils. Yeah, that's fairly common evidence that something does have FOC control, because you'll have 2 or 3 current sense coils or current sensors of some kind. A lot of, like all VESC stuff tends to use shunts, like the X9000. It uses 3 current loops like these. To get that, because that's part of the VESC spec to check phase amps in all 3, not just 2. But this is FAR driver development, and so they use 2. Anyway, there's not a whole lot more I want to show you on the top of the board, other than the fact that you can see, even like this little transistor was obviously soldered. Yeah, the repair work on here is everywhere. Gotta love that Kapton tape work. Holy cow, that is ugly. Man, yeah, I look at this and just go like, ugh. Yeah, look how ragged this is. They literally even bother cutting it. They just ripped it off. Yeah, didn't try to make it pretty. It's not stuck down. Yeah, I just look at this and just go like, damn. And I pulled it out of the shell like this. I didn't do that. I mean, that's just really ugly work. All right, let's flip this thing over and look over here. So you can see all the cruft and crud on all those solder joints. You know, once again, they didn't even bother to clean anything up because, well, it's Moto and we just literally don't care. Yeah, this is pretty much the only controller manufacturer where I run into stuff like this. A Far Driver doesn't do this. You know, I'm thinking of other Chinese manufacturers, okay? And Far Driver is Chinese. Votal doesn't do this. They're Chinese. Yeah, let's see, who else? Kelly is Chinese. Their boards are all washed. Yeah, there's probably one or two other ones. Oh, like Flip Sky. You know, that's all Chinese made too. That's a vest controller. That's all washed. Everything's nice and clean. It's only Moto of any of the Chinese manufacturers I know of that just literally leaves slop everywhere. Look at that. Look at all that crap on there. Yeah, little chunks of bits of solder and stuff. So, I went ahead and cleaned off part of this. And so here we go. Yeah, once again, some basic solvent and an old crappy screwdriver, or rather toothbrush, and now look how much better this looks. And that took a trivial amount of time to do. Okay, in the process, I didn't realize this was here, but I discovered something. You see this dark spot right there? I used xylene to clean this all off, thinking that was just some really, really stuck-on stuff. And it's not. It is a burn, all right? That is a burn on there, aka the MOSFETs, which are very close to the underside of here, from the middle power stage, exploded and scorched the underside of this board. Once again, more evidence that this is massively repaired and that there was some really awful things that happened to the power stages. This is a burn, okay? It does not wash off because the actual circuit board is cooked. Once I did that, I noticed this over here too. So you can see the same thing here. You see this dark area? Yeah, again, that's because the MOSFETs underneath it exploded and they scorched the board. So yeah, you can definitely see that burn mark right there. And here you've got another one. So once again, proof positive that this has seen catastrophic damage to it, and this logic board died and was refurbed, and the power stages underneath it exploded in flames and left scorch marks on here. So, good job, Moto, you suck. This is obviously a repaired board that suffered catastrophic failure. Yeah, you can see all the hand soldering on here. Don't necessarily care that's hand soldered. Yeah, you can see this as well. That's all hand soldered. I clipped off those legs on the Bluetooth module. Yeah, I'm going to still repurpose this, shift the Bluetooth module over so it can be on the top like it should be. Again, you can see all the crud, all the flux in here. I mean, look at all this crap on here. You know, I had somebody on Facebook claim that I did all this. I just absolutely was astonished. Yes, you're right. You know what? I deliberately put all this crap on here on purpose, just so that I could make Moto look bad. I put all of this on here. Yes, I did that, just so I could make Moto look bad. Do you have any idea how stupid you sound? Yeah, I did this. That's what was being claimed, was that I put all this crap on here just to make Moto look bad. All I can say is, are you really that delusional that you have to blame me for Moto's really crappy work and selling refurbished products as new? This is your conclusion. I must be making it up, and I did all of this. All I can say is, damn, that person is seriously delusional. I don't know about anybody else, but I just don't have the time of the day to waste out on doing stupid stuff like this. I have much better things to do with my time than to clutter up a board with crap like this just so I can make somebody look bad. My life is much more interesting than that. I simply would never bother. with, leaving crap all over things and obvious evidence of repairs. I just wouldn't. Show good faith, and KO Moto never does. Instead, they sell obviously massively repaired stuff as new. Yeah, bad, bad, bad. Anyway, hope to help some folks out. Take care. Bye.